Okay, all right, beta. So, any more doubts you are having, or can we move ahead to coefficient Bravo?
सर एक रडार प्लॉटिंग का था सर.
Okay, go ahead, beta. What is the doubt?
सर ग्रुप में भेजा है सर एक क्वेश्चन, सर उसमें.
Okay. Question, let us keep it for now. Let us see if we have time at the end of the class, then we will pick it up. Okay?
Okay, sir.
Otherwise, it will deviate your mind. So let's first cover up coefficient B, and towards the end, we will see it. Okay, so I'm putting on the presentation now.
एक्सक्यूज मी सर.
Go ahead, beta.
सर ये इसमें रियल ए के लिए तो आपने बोल दिया कि मर्चेंट वेसल पे नहीं होता है सर, लेकिन अपेरेंट ए तो हो सकता है ना सर?
हो सकता है बेटा.
तो वी आर नॉट काउंटिंग दिस वन नॉर.
बेटा अगर apparent take किसी शिप पे होगा because of any reason, as I told you, it can be because of manufacturing defect, lubber line not parallel to ship's fore and aft line, तो compass adjuster इस चीज को नोट करेगा. If it can be rectified, he will rectify it. He will get it rectified. If he cannot, then he will note this down in the deviation card as a index error. Got it, beta? Does that clarify your doubt?
ऐसा कल बताया था आपने.
Yeah, that's correct. चलें आगे बेटा. Okay, all right. So let's move on to coefficient Bravo. Now, how is this component generated? Let us see. The horizontal fore and aft component of the ship's magnetic field is called, just a minute, I missed one slide. Now let's move on to the second coefficient, that is coefficient B. The definition says coefficient B is the maximum value of the semicircular deviation which varies as the sign of the compass course. Now in the formula which I gave you, in that particular formula, what is that part which is proportional to or which varies as sine of the compass course? It is the second part of the formula, that is B sine course. Now the maximum value of that deviation is what is coefficient B. So you see this definition has been picked up, or you can easily remember this definition basis the formula. Coefficient B is the maximum value of the semicircular deviation which varies as sine of the compass course. That part of the deviation which varies as sine of the compass course, the maximum possible value what it can have is what is coefficient B. Now, what is the meaning of semicircular deviation? Now we know one circle is 360 degrees. So if a deviation carries the same name over the entire 360 degrees, if it is east and it remains east for the vessel heading on entire 360 degrees, it is called a circular deviation. A deviation which is of one single name for a semicircle, that is 180 degrees, and in the other semicircle, the remaining 180 degrees, it gets a opposite name. It is called as a semicircular deviation. To give you an example, Let us say on a particular ship, you observe the deviation from heading north to south. It is easterly deviation. And when the ship heads from south to southwest, that is 180, 190, 270 up to 360 in the southwest and northwest quadrant, the deviation is westerly. So you see now for 180 degrees, the deviation was east. For the next 180, it has changed to westerly direction. Such a deviation is called as a semicircular deviation. Now, if a deviation changes after every 90 degrees, for the first quadrant, the northeast quadrant, the deviation was easterly. For southeasterly quadrant, the deviation becomes westerly. For southwesterly quadrant, it again easterly, and for northwesterly quadrant, it becomes westerly. Means it changes after every 90 degrees. It is known as a quadrantal deviation. So semicircular deviation means that for 180 degrees out of the total 360, it will have one particular name, either east or west, and for the remaining 180 degrees, the name is going to be opposite to this one. So that is the meaning of the semicircular deviation. The causing factor for this particular coefficient is the horizontal fore and aft component of the ship's magnetic field. So beta, any doubts coming up to here? Great, let's discuss it further. Now, how is this component generated? Let us see. The horizontal fore and aft component of the ship's magnetic field is caused or generated by permanent magnetism of the ship as well as induced magnetism of the ship. So the contributing factor for coefficient B are both permanent magnetism as well as induced magnetism. The part of coefficient B generated by permanent magnetism is called permanent B, or in short PB, Papa Bravo. And that part of the coefficient B which is generated by induced magnetism is called induced B, or in short form IB. Let's now see the cause of permanent B on a ship. Now we are aware, concentrate your attention to the diagram, first diagram on the left hand side where the laser pointer is right now. Let's assume that this ship is being built in the yard on a northerly heading. If it is built in a northerly heading, the lines of force will be entering from the stern of the ship and leaving from the bow of the ship, giving the stern a blue polarity and the bow a red polarity. Now, if the ship was built on a southerly heading, then in that case, you will have a blue bow and a red stern. Now, these poles which are generated are permanent poles. So depending upon whether the ship was built on a northerly heading or a southerly heading, you will have a blue bow or a red bow. Now, when the ship has magnetism in this particular way, it has a blue bow and a red stern. How does this magnetism affect our compass? If you look carefully, this is the permanent magnetism of the ship in the horizontal fore and aft direction. What causes permanent B? So let us see its effect on our magnetic compass.
Excuse me, sir.
Go ahead, beta.
Sir, sorry to interrupt. Sir, in the first diagram, uh, in the this one which is heading is in the north.
Right.
So the polarity, the red one,
Right.
how it is coming the blue over here, sir? That I just got in doubt, sir.
Okay,
Blue,
beta.
blue.
Okay. Beta, when we discussed permanent magnetism, I told you that the permanent magnetism depends upon the heading on which the ship is built.
Yes, sir.
Okay, you can mute your mic now. Now, if the ship is built on a northerly heading, the magnetic lines of force are going to enter from the stern of the ship and they are going to leave out from the bow of the ship. Wherever the lines enter, that end gets a blue polarity, and wherever the lines come out or leave the ship, that gets a red polarity. So ship on a northerly heading has a blue stern because the lines are entering there, and has a red bow because the lines are leaving out from the bow. Is it clear now?
Okay, sir. Thank you, sir.
Okay, great.
Actually, sir, this broad rectangle, it was making the doubt here. The blue was here and then again red, so that's what I got confused.
Okay. The bigger squares are basically representing the Earth's poles.
Okay, sir.
Okay.
Sir, can you
Now,
go back to slide?
okay, beta. This
Sir, what about this plus P and minus?
plus and minus sign, beta.
Sir.
Okay. I will tell you about this a little later once we complete the coefficients. Every coefficient can be named as plus and minus. So it was very important when numericals were there, but now not much important. So I will tell you, once we cover all the coefficients, I'll tell you how it is named plus or minus. So just hold on for the moment. Okay, let's move ahead. Now this is a diagram which is showing us, this is the deviation diagram for coefficient B. It is showing us a ship which has a blue bow. You see everywhere at the bow we have a blue pole, and this ship is having a red stern. So this tells us that this particular ship was built on a southerly heading. So just now, as we saw in the previous slide, a ship which is built on southerly heading will have a blue bow, the lines of force will be entering there, and a red stern. Now, how does this permanent magnetic field of the ship in the horizontal direction, fore and aft direction, going to affect our compass? Let us see it heading by heading. Now, with the ship heading in the northerly direction, we have a blue bow and we have a red stern. The compass needle is shown in the middle of the ship. We know that the end of the compass needle pointing towards north is the red end, and the one pointing towards the south is the blue end. So we have the compass needle. Now when the ship is heading north, these blue and red poles of the ship are exactly north and south of our compass needle. So being exactly north and south of the compass needle, they do not generate any deviation at all. So there is no deviation on the northerly heading. Let's now assume the vessel has moved to a northeasterly heading in this particular direction. Now the blue pole has gone northeast of the compass, and this blue pole is going to attract the red pole of our compass, and the compass is going to deviate towards east. So you have a easterly deviation. The same thing happens with the red pole. The red pole of the ship, permanent magnetism, red pole of the ship, has gone to southwest of the compass, and it attracts the blue end of the compass towards it, giving the compass a easterly deviation. So you can see now on a northeasterly heading, a easterly deviation is generated. When the ship goes to a easterly heading, 090 heading, now you see the blue pole is to the east of the compass, and the red pole is to the west of the compass. They are at right angles to the poles of the earth, and now in this location they generate maximum deviation. The blue pole at the bow attracts the north end or the red end of the compass towards it, and the red pole at the stern attracts the south end of the compass towards it, giving it maximum easterly deviation. When the ship heads in a southeasterly direction, the blue bow goes to southeast of the compass, and this blue bow repels the blue end of the compass needle, that is the south end of the compass needle. Similarly, the red pole of the ship at the stern repels the north end of the magnetic needle, again giving it a easterly deviation. But the magnitude of the easterly deviation starts to reduce now because the ship's poles are coming in line with the magnetic field of the earth. Maximum deviation is generated when the ship's poles are at right angles to the magnetic field of the earth, which happened on easterly heading, and minimum deviation is generated when the poles are aligned with the poles of the earth, which happened on northerly heading. If ship pole and earth pole are aligned, there will be no deviation at all, and if the ship's poles and earth pole are at right angles, there will be maximum deviation. So that's why in the southeasterly heading, the deviation is reduced now, but it is still easterly. When the ship goes on southerly heading, even though the blue pole is closer to the blue end of the compass needle and the red pole is closer to the red end of the compass needle, they are still not able to generate any deviation. The red and red poles are repelling, blue and blue poles are repelling, but the strength of the poles of the ship is much weaker as compared to the strength of the Earth's poles. So that is why they are not able to turn the compass needle by 180 degrees. If the ship's field was more powerful, it would turn the compass needle by 180 degrees and the needle will start pointing south. But since these poles are much weaker, the magnetism of the ship is much weaker as compared to the magnetism of the earth, they are not able to generate any deviation at all. When the ship goes on southwesterly heading, you can now see that the blue pole at the bow repels the blue end of the compass needle. Similarly, the red pole at the stern of the ship repels the red end of the compass needle, generating a westerly deviation. When the ship is heading in the westerly direction, this westerly deviation becomes maximum because the poles of the ship are at right angles to the poles of the earth. The blue pole to the west of the compass needle attracts the red end towards it, generating a westerly deviation. Similarly, the red pole of the ship at the stern attracts the blue end of the compass needle, generating a westerly deviation. So maximum westerly deviation is generated on westerly heading. With the ship going on northwesterly heading, the deviation is still westerly, but the magnitude is reduced because the ship's poles are now coming in line with the magnetic poles of the earth. Coming back to north, the deviation becomes 0. So you see, from 000 to 180, the deviation was easterly, and from 180 to 360, the deviation was westerly. This is what we mean by a semicircular deviation. For one semicircular, the deviation has a single name. For another semicircle, the deviation has a opposite name. So therefore, it is called as a semicircular deviation. Now, another important thing which you can see from this diagram is that these poles of the ship also affects the directive force at the compass location. What is this directive force? Directive force is the strength of the magnetic field at the compass location which makes it point towards the north direction. Now with the vessel heading on the northerly heading, you can see that the poles of the ship are matching with the poles of the earth. The earth's north pole is a blue pole, and the ship structure also has a blue pole north of the compass. So this blue of the earth and blue of the ship are adding up, increasing the magnetic field. Similarly, south of the compass we have the red magnetic pole of the earth, and the ship's pole is also red. So earth's red and ship's red, they also add up to the directive force. So in this particular heading, northerly heading, the directive force is increased to its maximum. When the ship goes on easterly heading, in the easterly heading, the red and blue poles of the ship are neither north of the compass nor south of the compass. They are exactly east-west of the compass. Being east-west of the compass, they do not have any effect on the directive force. So the directive force is unchanged at this particular location. Now with the ship heading in the southerly direction, you see now the poles of the ship are opposite to the poles of the earth. South of the compass, we have the blue pole of the ship and the red pole of the earth. North of the compass, we have the red pole of the ship and the blue pole of the earth. So with the ship pole and the earth pole becoming opposite, the directive force is reduced. So there is a maximum reduction in the directive force with the ship heading in the southerly direction. So go ahead with your doubts now, beta.
Sir, I had a doubt with the northeast heading. In fact, all intercardinal points.
Okay.
Sir, since there is a blue pole and the compass and the compass is having a red pole, it should attract now. So then the DF force should be reduced in the northeasterly heading.
Okay. Beta, basically the directive force is whether the ship's poles are adding up to the magnetism of the earth or they are opposing the magnetism of the earth. Now, whenever you have a blue pole of the ship, which is northward of the compass, okay, northward of the compass, on a 000 heading, it is exactly north, but on northeasterly heading, it is still northeast, so still has a northerly component. It will add up to the strength of the blue pole of the earth. So that is why the directive force is increased.
But it is causing some deviation, no, sir? So it's not like on the perfectly magnetic north. It will be
It is
slightly
causing
deviated.
a deviation. Yes,
Yeah.
it is easterly deviation. Now you see the deviation is basically a force or generated by a force which acts in the east-west direction. Okay. And this directive force is affected by the north-south component of the ship's magnetism. Let me try to explain it in another way. You assume that the ship's magnetism is like a vector, okay, going from red to blue. Now, in the northeasterly direction, this vector is pointing in 045 heading. If you break it up into north-south component and east-west component, the north-south component of this vector increases the df, and the east-west component of this vector generates the deviation. Are you able to visualize that way?
Yes, sir. Now it's so basically, the directive force is just if it's north, the pole is north of the how you call pointing towards the northern hemisphere, then its DF is increasing all the time.
Right, that's correct.
Okay, understood.
And you can do a simple thing also to check whether DF is increasing or decreasing. At the middle of the compass, at the center of the compass needle, draw a horizontal line. Draw a horizontal line and see whether the blue pole is above it or below it, ship's blue pole. If it is above that horizontal line, that means it is matching with the blue pole of the Earth, the DF will always increase. And whenever the blue pole of the ship is below or southwards of that horizontal line, it will always reduce the directive force.
Okay. Yeah.
Okay.
Sir, one more.
Go ahead, beta.
So in this,
One
which
by one.
heading the directive force will be higher?
Directive force will be maximum on northerly heading, beta, north heading.
Okay, so the blue pole is north heading. Okay, copy that, sir.
Yeah, here the blue pole is exactly north of the compass, giving a maximum increase in the directive force.
Sir, that means if the active force is at maximum, the chances of deviation is minimum.
Certainly, but that becomes a little complicated. But what you said, the relationship is correct. As the directive force increases, the deviation reduces. Okay? इसको आप एक और तरीके से भी समझो. Deviation generate करने के लिए जो ship के poles हैं, they have to be misaligned with the poles of the earth. अब आप south heading पे भी देखो. South heading पे the directive force is minimum because the ship's blue pole is opposing the earth's red pole, but still the deviation is zero. Because for generating deviation, the ship's magnetism has to has a easterly or westerly component. The easterly or westerly component of the ship's magnetism is what generates the deviation. Getting clear, beta?
Yes, I got it.
Okay, great. Now, beta, did you get any disturbance, any background noise while I was explaining this?
Negative, so no, I didn't hear anything.
Okay, all right, great. यहाँ से एक निकल रहा है रोड से एक प्रिसेशन इज गोइंग ऑन सो दैट्स व्हाई आई वाज आस्किंग सो इट्स ओके परफेक्ट द टीम्स मैजिक इज वर्किंग गो अहेड बेटा गो अहेड
सर ये डीएफ का एप्लीकेशन
not much practical application beta only thing is whenever you explain a coefficient and make a diagram these two things are required in the explanation. One is the effect of that coefficient on the deviation and second is the effect of that coefficient on the directive force. No practical application further.
No, sir.
So when
Not
we
even
make
in
the
the
diagram, we have to explain both, sir. So for exams,
Beta,
when we make the diagrams, we have to explain both, sir.
yeah, that's correct, beta. You have to make the diagram. You have to mention what is the effect on deviation, what is the effect on directive force. Okay, these are the two things which are required in the explanation. More than this, the directive force is not used anywhere. Clear, beta? Understood?
Yes, sir. Thank you.
Great. चलें आगे.
So just want to confirm this blue pole and the red pole, are they HSI only? Horizontal soft iron or?
No, beta, these are permanent poles. So this is because of permanent magnetism of the ship. So soft iron is not involved here.
Okay, sir, permanent poles. Okay.
That's correct. Soft iron will come, horizontal soft iron will come when we go to coefficient delta.
Okay, sir. Like
Go ahead,
in
Neeraj.
coefficient A, we had this HSI, so I was confused with that only. Okay.
Yeah, that's right. Coefficient A was HSI and it was induced magnetism which was generating coefficient A. For Bravo, permanent B, it is only the hard iron and permanent magnetism of the ship.
Okay.
So, sir, for seeing the intensity of the directive force, we have to see this where is the blue pole located as per the compass. So, if it will be the north, then the DF will be increased. But if the red
Exactly,
pole
beta.
is at north of the compass, then it will be reduced, right?
That's correct, beta. That's correct. The closer ship's poles are to the Earth's poles and they are matching, this will lead to an increase in directive force. And if the ship's poles and Earth's poles are opposite to each other, it will reduce the directive force.
Sir, can you please explain this 045 heading, why it is increased in this? Telling on.
Why the DF is increasing? you want to ask that why the directive force is increasing on a northeasterly heading, correct, beta?
Yes, sir, that's correct.
Okay. Now, beta, you see the ship's blue pole close to the bow. Tell me, this blue pole is northwards of the compass or southwards of the compass?
Sir, it is northward of the compass.
So whenever the blue pole is northwards of the compass, the directive force will always increase. Magnitude will vary depending upon the position of the blue pole, but whenever it is northwards of the compass location, it will always increase the directive force.
Okay, sir, copy, got it.
Clear, beta? चले आगे. Okay, Vaibhav, what's your doubt?
Sir, if suppose the same ship goes, we had the north red pole at the bow and blue pole at the stern. So the
Right.
all the northern components will have decreased, reduced DF, and the deviation will remain the same, correct?
You mean to say if the poles are interchanged?
Yes,
The
sir.
blue pole comes to the stern, red pole goes to the bow.
Yes, sir.
Okay. Now, if the ship is built on a opposite heading, this ship was built on a southerly heading. That's why it had a blue bow and a red stern. If you pick up the example of a ship which is made on a northerly heading, so in that case, the stern will be blue and the bow will be red. And in that case, जो आपकी डायरेक्टिव फोर्स है वो बिल्कुल ऑपोजिट हो जाएगी इससे. On all the northerly headings, the directive force is going to reduce, and on all the southerly heading, the directive force is going to increase.
Yes, sir.
Okay.
But the deviation will
डेविएशन
remain the
में
same.
भी चेंज आएगा. डेविएशन में भी चेंज आएगा बेटा. उस केस में डेविएशन के जो साइंस हैं वो चेंज हो जाएंगे. नॉर्थ ईस्टर्ली हेडिंग पे यू विल हैव ए वेस्टर्ली डेविएशन देन, because the bow will be
Okay,
red.
yes, sir. Yes,
The
sir,
red
yes,
and
sir.
red are going to repel, generating
Yes,
a
sir.
westerly deviation.
Yes, sir, yes.
Okay.
Copy, sir. Thank you, sir.
If you want, you can explain it that way also. That would also be correct.
Okay, sir.
So it can be done that way. But book में उन्होंने यही वाली example ली थी, so that's why I have shown you the same example.
Okay, sir. Thank you, sir.
Great, beta. Any more doubts coming in?
Sir, just for simplicity, during the exams, we'll better draw whatever you are showing. So I think that should suffice. We'll not create any
एक उसमें
confusion.
चेंज या एक उसमें चेंज आएगा बेटा. एग्जाम में आप रेड कलर यूज नहीं कर पाओगे, so you will have to show it by writing a capital letter R. Okay, you can show it by writing capital letter R and B. मैंने यहाँ रेड और ब्लू यूज किए हैं, बट आप रेड नहीं यूज कर पाओगे.
सर रेड पेन नहीं यूज कर सकते?
No beta, cannot use. Red is reserved for the paper checker. Okay.
So we
Green
cannot use
also
any
cannot be
colors.
used. Green is reserved for rechecking. So you can use blue and black. I believe blue and black are both allowed, but still read the instructions on the paper. Sometime even black is not allowed. Okay beta, clear? चलें आगे?
सर पेपर पे तो ऐसा कभी लिखा नहीं है सर, ब्लैक अलाउड ऐसा कभी पढ़ा नहीं सर.
Yeah, it's possible. Generally, blue and black are both allowed. So just see, sometimes somewhere black also may be not allowed. So usually 99% of the times black, blue are both allowed. Black, blue as well as a pencil. These three are allowed.
Okay, sir.
Sir, as I remember, it was either blue or black, but we can't use both, and also pencil. We can use one of the two. ऐसा लिखा था मेरे को याद है सर.
Correct, sir. Correct. We cannot.
Okay. Okay, so that also could be there, beta. So if that is the case, then whatever you are using, please use that only. Don't use the other color, and show these red and blue by capital letter R and B.
All right.
Okay, great. So let's go ahead, Rajat.
So this diagram may the poles of Earth are not mentioned. Like I mean the magnetic
Yeah,
north and
you
south.
can make the poles, beta.
Yeah.
You can make the poles. The red one will come on top. Sorry, the blue one will come on top, and the red one will come at the bottom. Okay. Moving ahead now.
So these poles will be always same, Earth poles, blue and red.
Yeah, Earth pole will not change. The North Pole will always be blue and the South Pole will always be red.
Okay.
Now moving on to the correction of coefficient B. Coefficients are always corrected on the heading on which they produce maximum deviations. Now the first thing which the compass adjuster needs to know is on which heading should I correct coefficient B. So we should always remember coefficients are always corrected on the heading on which they produce maximum deviation. Now coefficient B produces maximum deviation on easterly or westerly heading. So that is where it is corrected. For the coefficient to cause maximum deviation, it should act perpendicular to the needle. You remember on easterly or westerly heading, the blue and red pole of the ship are at right angles to the magnetic field of the earth, or they are acting perpendicular to the compass needle, giving maximum deviation. Now, basic principle which is followed in correcting the compass is to cure like with like. Now, what do we mean by curing like with like? It means permanent magnetism deviation are cured or corrected by using permanent magnets. Induced deviations are corrected or cured using induced magnet. So permanent is corrected with permanent, induced is corrected with induced. So same thing is mentioned here. Permanent deviation is cured or corrected with permanent magnets. Induced deviation is corrected with induced magnetism. Moving ahead now. So permanent B, which is caused by ship's fore and aft horizontal permanent magnetic field, is therefore corrected using fore and aft permanent magnets which are placed horizontally. Now these magnets are so placed as to produce a permanent magnetic field at the compass location exactly equal and opposite to that of the ship. Now how we do that? Let us try to understand using this diagram. In this diagram, we see the same ship which we discussed for deviation. This ship is having a blue bow and it is having a red stern. Now you see the binnacle, this is the binnacle, and the compass is fitted at this particular location. Now these blue and red poles, why were they generated? Because this particular ship was constructed on a southerly heading and during its construction it acquired these permanent poles. Now because of this blue and red poles of the ship, a magnetic field is generated. You can follow the laser pointer. The laser pointer now is moving on the magnetic field generated by the permanent poles of the ship. You see the magnetic field lines come out of the red pole and they go back into the blue pole. That is how the magnetic field lines are acting at the compass location. So what we do to correct it? We use fore and aft permanent magnets. We place them in the binnacle just below the compass and we place them in such a way that their poles are opposite to the poles of the ship. So we had the blue pole at the bow. When we place these correctors, we place the blue pole towards the stern. You see, we have red pole of the corrector magnet towards the bow. So when you place these magnets in the binnacle, they generate a correcting field. Right now the laser pointer is on the correcting field and you can see that the direction of the correcting field is opposite to the direction of the deviating field. So when you place these corrector magnets in the binnacle in the fore and aft direction with their poles opposite to the poles of the ship. Forward of the ship had a blue pole, forward of this corrector has a red pole. So with the poles opposite to the poles of the ship, they generate a opposite field, thus correcting the deviation caused because of permanent B. Any doubts up to here, beta? Great, let's move ahead.
Sir, one moment.
Go ahead, beta. Any doubts, beta? Go ahead.
सर जो प्रीवियस स्लाइड में था कि करेक्शन शुड बी डन ऑन द हेडिंग ऑन विच दे प्रोड्यूस मैक्सिमम डेविएशन, तो वो वाला साइड जो स्लाइड है वो कोफिशिएंट बी के लिए ही है ना?
For all the coefficient, the statement is correct for all the coefficient, beta.
ओके सर, फॉर ऑल द कोफिशिएंट.
ओके, ये भी मैं आपको एक्सप्लेन कर देता हूँ. अब बेटा अगर आप कोई कोफिशिएंट करेक्ट कर रहे हो, लेट अस से एनी कोफिशिएंट ब्रेवो इज देयर, आपने इसे करेक्ट करना है. हमें पता है कि कोफिशिएंट ब्रेवो ईस्ट और वेस्ट हेडिंग पे स्ट्रॉन्गेस्ट है. ओके, तो हम जहाँ पे वो स्ट्रॉन्गेस्ट है वहीं पे उसे ऑब्जर्व करेंगे और वहीं पे उसकी करेक्शन होगी. अगर आप नॉर्थ और साउथ हेडिंग पे चले जाओगे जहाँ पे वो है ही नहीं, देन व्हाट आर वी गोइंग टू करेक्ट? वो पुराने सीरियल याद है बेटा, वो रामायण महाभारत में वो समटाइम राक्षस जो है वो आते थे, ऐसे दिख रहे हैं तो उसको मारने की कोशिश करते हैं तो वो गायब हो जाता है. सो जहाँ पे वो गायब हो गया वहां पे तो हम उसको मार ही नहीं सकते ना. वी हैव टू किल द डेमन वेयर इट इज विजिबल. सो इसी तरह से जहाँ पे वो कोफिशिएंट स्ट्रॉन्गेस्ट है, हमें अच्छे से दिखाई दे रहा है, दैट इज वेयर वी आर गोइंग टू रेक्टिफाई इट और करेक्ट इट. राइट?
ओके सर.
ओके. These magnets which we use, the fore and aft magnets, they are bar magnets of circular cross section. They are 8 inches long and they come in two thicknesses, either 3 by 8 inches or 3 by 16 inches diameter. So where more powerful magnets are required, we use the thicker ones, that is 3 by 8 inches, or where less powerful correctors are required, we use 3 by 16 inches diameter magnets. The size is decided by the compass adjuster. Once the ship is constructed and it goes out for sea trials, the compass adjuster checks the magnetism of the ship and decides upon whether he wants a thicker corrector or a thin corrector magnet. Slots are provided in the binnacle below the compass and the magnets are placed two in a row side by side. So when we place these corrector magnets, they are always placed in pairs. So one of the magnets is slightly to the starboard of the compass, another magnet is to slightly port of the compass. They are always placed in pairs. Now why are they placed in pairs? The reason for that is exactly in the middle of the binnacle or exactly below the compass, you have a periscope which is going into the wheelhouse. It is with the help of the periscope that you are able to see the magnetic compass at the helmsman location from the bridge. So because of this periscope, we cannot have the corrector magnet exactly below the compass location. I'll show you another diagram explaining this. Moving ahead. This is the diagram of a binnacle. Now you see this particular plate which is fitted here. This plate carries the authwardship magnet tray. This is for correction of coefficient C. And you see this particular plate which is fitted here. Now this plate carries the fore and aft magnets. Fore and aft magnets correcting coefficient permanent B. So when you open this plate, you will have access to these magnets. Now you can see these magnets here. These are the magnets which are fore and aft magnets here. Fore and aft magnets. You see this is the pipe which is going down, the periscope pipe. Also you see a small bucket hanging with a chain. This is known as a healing error bucket. So this is how the corrector magnets are placed to correct coefficient B, permanent B. Go ahead, beta.
Yes, sir. Understood.
Okay, great.
Sir, the number of magnets to be placed to correct the PB would depend upon what, sir? Or is it fixed, like always two?
Okay, no, it is not fixed, beta. Later on, when we complete the coefficients and we go for correction, then I will tell you how each coefficient can be calculated. The compass adjuster can calculate what is the coefficient Bravo for that particular ship. The formula for that is deviation on northerly heading, deviation on easterly heading minus deviation on westerly heading divided by 2. So he will first calculate it, and then he is going to place only that many number of magnets which correct the coefficient.
Okay.
Say for
So
example,
maximum, yeah. Okay.
किसी शिप में आपने coefficient B compass adjuster ने check किया and it comes to 3 degrees. So he is going to place the magnets which turn the card by 3 degrees only. So he can use 1 pair, 2 pair, 3 pair as he requires.
Okay, sir. Understood.
So one pair means both the magnet on each side, like one port and one starboard, or both the magnet on port or starboard?
One pair means one magnet to the starboard side of the periscope and one to the left side of the periscope. That is one pair, beta.
Understood, sir.
So, sir, the adjuster will keep these magnets always in pair, sir, or its strength depend on the sides, according to the side, to पिछले side.
Beta, for a normal merchant vessel, they should always be in pairs. लेकिन अगर हमारे शिप का स्ट्रक्चर पोर्ट और स्टारबोर्ड में थोड़ा सा अनसिमेट्रिकल है और हमारी कंपास एग्जैक्टली सेंटर लाइन में नहीं है, द कंपास इज स्लाइटली टू पोर्ट और स्टारबोर्ड, इन दैट केस देयर इज ए पॉसिबिलिटी कि स्टारबोर्ड साइड में या पोर्ट साइड में मैग्नेट्स के नंबर इक्वल ना हो. But for all normally constructed merchant vessel routine construction, you should have a pair, one on starboard and one on port, for all the magnets which you are using.
Copy, sir.
चलें आगे बेटा?
जी sir.
Very good. Let's go. Let's now move on to the second part of coefficient B, that is induced B. Induced B is caused by horizontal fore and aft magnetic field at the compass due to the induced magnetism in the vertical soft iron forward or aft of the compass. So you see, again it is a horizontal fore and aft magnetic field, but it is generated because of induced magnetism in the vertical soft iron forward or aft of the compass. Let me show you how it is generated. The vertical soft iron which we have on ship could be the forward mast, it could be a crane, it could be the funnel, or it could be a aft mast or a crane aft of the compass location. Now all these vertical structures will be induced by the magnetic field of the earth, by the vertical component, Z component of the earth. If this particular ship is in northern hemisphere, the lines of force go vertically downwards, so they will be entering from the top end of the VSI and leaving out from the bottom end of the VSI. So the top end where they are entering gets a blue polarity, and the bottom end where they are leaving out gets a red polarity. So you see all the top poles of the vertical structures are blue. The top pole of the funnel is blue. The top pole of the forward mast, aft mast, or the cranes is blue. The bottom poles of all these vertical structures are red poles. Now, out of these two, what affects our compass is the pole which is closer to the compass. And in this case, the top of the top poles, which are the blue poles, are almost in line with the magnetic compass, and they affect our compass. If the same vessel goes in the southern hemisphere, then the magnetic lines of force come out of the Earth's surface. So you see, with the same vertical structures in the southern hemisphere, the polarity is going to change. The lines will now enter from the bottom of these vertical structures, giving it a blue polarity, and it will come out from the top of these vertical structures, giving it a red polarity. So these being induced magnets, their polarity changes when the vessel changes from northern hemisphere to southern hemisphere.
Sir, yeah.
Go ahead, beta.
Sir, this induced B will also be there in a horizontal direction also. So why we are taking?
You mean to say horizontal soft iron, beta?
Yes, sir.
Okay. Now, horizontal soft iron generates a deviation which is of a different nature. That will fall under coefficient delta. So when I go to delta, there we will be using the horizontal soft iron structures.
Puppets. Yes.
चलें आगे बेटा.
Sir,
Yes.
in this can't it is caused by horizontal fore and aft magnetic field, and then it is saying that it is by vertical soft iron node. Can you explain again?
ओके बेटा. सो अब ये डाउट आ रहा है कि ये स्ट्रक्चर तो वर्टिकल है, लेकिन ये हॉरिजॉन्टल फोर एंड आफ्ट डायरेक्शन में फील्ड कैसे जनरेट कर रहा है. नाउ दिस स्ट्रक्चर इज वर्टिकल, but you see the bottom pole of this structure are not affecting the compass because they are too far away. What is affecting the compass is only the top pole of these structures. Now, whether the top pole was generated because of permanent magnetism, you had a blue pole at the bow, red pole at the stern, or it is generated on top of a mast because of induced magnetism, both ways it is causing a magnetic field at the compass location in the fore and aft direction. The structure is vertical, but we are only affected by the top pole, and this top pole is more or less in line with the compass card, generating a horizontal field at the compass location. Getting clear, beta?
Okay, sir.
Okay, great. Let's move ahead. So as we discussed just now, the compass is generally situated at level with the top poles of the masts and the funnel. The top poles therefore affect the compass more as compared to the bottom poles of these vertical soft iron structures. We are aware that the compass is affected by that pole of the magnet which is closer to it. So we can see that the compass is situated in line or at level with the top poles of these vertical soft iron structures. So the top poles affect the compass more, and the bottom poles, being far away, do not affect our compass. Second thing to note is that funnel is the largest vertical soft iron structure on board. We may have the masts, we may have the cranes, aft mast, but the amount of steel which is used in construction of the funnel is much more, as well as the size of the funnel is much more as compared to the size of masts or cranes. So therefore, funnel affects our compass most predominantly among all the vertical soft iron structure. So the effect of the funnel being the most predominant is considered mainly for induced B. So moving ahead now, beta. Any doubts, beta?
सर कंपास के पीछे तो मास्ट भी होता है, तो अगर मास्ट का जो अपर पार्ट है वो तो कंपास से ठीक है दूर होता है, लेकिन वो जिस मंकी आइलैंड पे जिस डेक पे एंड होता है वो तो रेड बनेगा, वो तो कंपास के नजदीक होगा, वो नहीं इफेक्ट करेगा सर मास्ट से ज्यादा, फनल से ज्यादा?
अब बेटा उसका डिस्टेंस तो मास्ट से कम, सॉरी फनल से कम है, but usually the amount of steel which is used in construction of the mast is much lesser. So it offsets or reduces the effect of the funnel, but is not able to counteract and overpower.
Okay, sir.
Okay. Let us now try to understand the deviation generated by induced B coefficient. So you can see the ship on cardinal and intercardinal headings. And we can see the compass needle. The north end of the needle is red, the south end of the needle is blue. And we have a ship having a vertical soft iron aft of the compass, abaft of the compass. And as we just now discussed, that out of all the vertical soft iron structures, the funnel has the largest structure, the maximum amount of steel which is used in the funnel as compared to the mast, the crane. Also, funnel is having the biggest size among all the vertical soft iron structures on board. And thirdly, the funnel is also located very close to the compass. The top of the funnel is almost in level with the compass card. And being the largest structure and also being very close to the compass as compared to maybe the forward mast or the cranes, it gives us the most predominant effect. Now, another important thing to understand here is if we have a vertical structure forward of the compass and a vertical structure aft of the compass, they are going to cancel out each other. Two vertical structure forward and aft of the compass are going to cancel out each other. But as far as the funnel is concerned, the funnel is abaft of the compass and there is no comparable structure forward of the compass in comparison to the size and the amount of steel used as is done in the funnel. So that's why you see that in this deviation diagram, the funnel is considered as the vertical soft iron structure on board, and this particular ship is considered to be in the north hemisphere. In the north hemisphere, the magnetic lines of force, they go vertically downwards into the surface of Earth. So they enter from the top pole of the funnel, giving it a blue polarity, and they leave out from the bottom pole of the funnel, giving it a red polarity. The bottom pole being far away from the compass doesn't have much effect, whereas the top pole is the one which affects our compass. So let's now see the deviation generated because of the funnel. With the ship heading north, we have this blue pole at the top of the funnel abaft of our compass. It is exactly south of the compass needle. Even though the blue pole tries to repel the blue end of our compass magnet, it is not able to do that because the magnetic field generated by the funnel is much weaker as compared to the magnetic field of the Earth. Now the compass is pointing northwards, the red pole of the compass is pointing northwards because of the Earth's magnetic field. And the funnel's blue pole is trying to rotate the compass and turn it by 180 degrees. It wants the red end to point southwards where the funnel is. but it is not able to do that because the magnetism of the funnel is much weaker as compared to the magnetism of the earth. Now then the ship goes on a northeasterly heading. On the northeasterly heading, the blue pole of the funnel comes to southwest of our compass needle. Now, when it comes southwest of the compass needle, it is no more aligned with the magnetic field of the Earth. So it starts repelling the south end of the compass needle, and the compass needle turns anti-clockwise, or a westerly deviation is generated. When the ship goes to easterly heading, on a easterly heading, the blue pole of the funnel is at right angles to the field of the earth. It is exactly west of the compass. It is right angles to the field of the earth, and it provides or generates the maximum deviation. This blue pole of the funnel attracts the red end of our compass magnet and repels the blue end of our compass magnet, generating maximum westerly deviation. When the ship goes on southeasterly heading, in a southeasterly heading, the funnel blue pole is to the northwest of our compass, and again the blue end or blue pole of the funnel attracts the red end of our compass needle, and a westerly deviation is generated. But the westerly deviation now starts to reduce. Why the westerly deviation reduces is because the blue pole, which is generating this deviation, is now no more at right angles to the field of the earth, and it has started coming in line with the earth's magnetic field. Any pole, when it generates deviation, it generates maximum deviation when it is at right angles to the field of the earth. So when it is at right angles to earth's magnetic field, it will generate maximum deviation. And when it is aligned with the earth's magnetic field is running north-south. So when a pole comes north or south of the compass needle, it does not generate any deviation at all. So when the ship goes on southerly heading, the blue pole of the funnel comes exactly north of our compass, north of the compass needle. And since it is aligned with the magnetic field of the earth now, it does not generate any deviation at all. So no deviation on south heading. When the ship heads southwest, the blue pole is to the northeast of the compass, and this blue attracts the red pole of our compass magnet, the compass needle, and it generates a easterly deviation now. So easterly deviation is generated. When the ship moves on 270 heading, ship is heading west, then the blue pole of the funnel is now exactly east of our compass needle. So at this location, it is at right angles to the Earth's field. It attracts the red end of our compass needle and repels the blue end of our compass needle. The compass needle turns clockwise and generating a easterly deviation. At this point, the easterly deviation is maximum. What is the reason for that? Because the pole which is generating the deviation is at right angles to the magnetic field of the Earth. When the ship goes on northwesterly heading, this blue pole has come southeast of the compass needle, and it now repels the blue end of our compass needle, generating a easterly deviation. But the amount or magnitude of the deviation is reduced now because the pole is no more at right angles to the Earth's field, and it has started coming in line with the field of the Earth. So we can see that the deviation which is generated is semicircular from 000 to 180. The deviation generated is westerly. A westerly deviation is generated, and from 180 to 360, a easterly deviation is generated. Maximum deviation is generated on easterly and westerly courses, and zero deviation is generated on northerly and southerly courses. So you can see it is proportional to sine of the compass course. Sine 90 or sine 270 has a magnitude of the pole on the funnel is blue polarity. So with these poles having opposite polarity, it reduces the directive force. When the ship is heading south, then the blue pole of the funnel and the blue pole of the earth, they match, increasing the directive force at the compass location. So
So
whenever the
voice is
ship
gone.
is on a northerly component heading, northeast, north or northwest, the directive force is reduced because this funnel's blue pole is southward of the compass, giving or reducing the directive force. Whereas when the ship is on a southerly component heading southeast, south, or southwest, the directive force is increased because the blue pole of the funnel is north of the compass needle. Go ahead with your doubts, beta.
सर ये जो ईस्टर्ली कोर्स पे है नो चेंज इन डायरेक्टिव फोर्स नो चेंज
Right.
विथ रिस्पेक्ट टू व्हाट सर
Okay. No change with respect to if the compass was located uh, on a wooden ship, okay, where there was no ship's magnetism. So the directive force is exactly same as what it was without the ship structure.
Okay, so it would show basically magnetic north, no?
No, beta, no, 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 no,
Yeah, but
no.
it's also okay. It's also attracting.
See, the ship's magnetism affects the deviation of the compass needle, deviation,
Hmm.
and it also reduces or increases the directive force in that area. Both are opposite things. The deviation is generated because of the east-west component of the ship's magnetism. अगर शिप के मैग्नेटिज्म का ईस्ट वेस्ट कंपोनेंट जितना स्ट्रांग होगा डेविएशन उतनी ही ज्यादा होगी and the directive force is affected by the north south component of the ship's magnetism.
सर ये जो लास्ट में बोले सर नॉर्थ साउथ कंपोनेंट होता सर ईस्ट वेस्ट will be making the maximum deviation, na, sir?
That's correct, beta.
And north south component will be of the earth magnet that we are considering.
No, north south component of the ship's magnetism will affect the directive force at that location.
Copy, sir, will affect that. Copy.
Sir, can we remember the directive force change as if the blue of the ship is in the same direction as the earth, the directive force will increase. Can we remember it like that?
Yes, beta, certainly you can remember it. It is because of that only.
Right, sir. Thank you. Thank you.
Okay. Go ahead, beta.
हम लोग जैसे मैग्नेट में वेरिएशन था डेविएशन था वेरिएशन इज एंड डेविएशन के लिए इट हैज कंपोनेंट इन 3 डायरेक्शंस तो उसके लिए हम लोग फॉर्मूला लिए ए वी आर कंसीडरिंग द इफेक्ट ऑन हॉरिजॉन्टल सॉफ्ट आयरन व्हेन इन अनसिमेट्रिकल वे तो वो एक तरीके से इंडेक्स एरर की तरह हो गया
राइट
बी कंपोनेंट को हम लोग दो पार्ट्स में डिवाइड किए एक परमानेंट मैग्नेटिज्म में
राइट
which is affecting because of ship fore and aft permanent magnet.
Yes,
And
correct.
IB, which is because of induced, which is maximum effect of our funnel. बस अभी तक
That's
इतना
correct.
ही हम लोग scale.
That is correct, beta. Right. Whatever you said is right.
Thank you, sir.
सर वन क्वेश्चन.
बोलो बेटा.
सर जो कोफिशिएंट ए था उसमें सारी ईस्टर्ली डेविएशन थी, राइट?
राइट.
और बी में ईस्टर्ली भी है, वेस्टर्ली भी है. तो अगर जैसे क्वेश्चन आता है राइट अबाउट डेविए ए या बी के बारे में, तो ये ऐसे डायग्राम बना के ये पॉइंट्स लिख दे, दैट इज इनफ या और भी लिखना पड़ेगा?
नहीं, that's enough, beta. You just make this particular diagram and explain the reason in your own words. Okay. You don't need to explain in so much detail as I am explaining you. But आप इसे अगर हर एक heading पे 1 or 2 lines लिख दोगे, 8 or 16 lines along with this diagram, that takes care of your answer.
ओके सर.
Okay, great.
सर आपने जैसे बोला था funnel affects this induced B. So what
Right.
about this ultra large container carrier sir, जिसमें funnel पीछे की तरफ होता है and accommodation आगे की तरफ जिसमें compass बैठा रहता है? In those case, this induced B is there?
Beta, in normal merchant vessels also the funnel is aft of the accommodation only or aft of the compass only. So the effect will be same. Only thing is कि अगर आपकी compass में और funnel में distance increase हो जाता है, तो ये induced B का जो coefficient है ये weak हो जाएगा. Because जैसे जैसे distance increase होगा, the effect of the funnel on the compass will reduce. So that is the only change which will happen.
Okay sir.
Okay. हाँ, अगर कोई ऐसा hypothetical ship हो जिसमें funnel आगे लगी हो और accommodation aft में हो, पीछे हो, so in that case the effect is going to reverse because this pole is going to go forward of the compass then.
Okay.
Okay. Any more doubts, beta?
Sir, one question. Sir, the correction for all these coefficient by means by slewing of the balls or placing the mark correctors. How do we do it? We'll do it later, right?
Yeah, after this I'll be doing the correction. As we discuss the coefficients, उसके साथ साथ ही correction करेंगे बेटा. अभी मैं IB की correction आपको बताऊंगा.
Okay, sir.
Okay.
Sir, one thing. Since
go ahead.
we are talking about correction, sir, Flinders bar इसके लिए है क्या sir? Just
या इसी के
yes
लिए
or no?
बेटा. Just hold on. अभी दिखा रहा हूँ.
Okay, okay sir.
Let's now discuss the correction procedure, the concept behind the correction of induced B. We use like cures like principle. That means permanent deviation is corrected using a permanent magnet. Induced deviation is corrected using a induced magnet. Now, since this induced B is generated because of magnetism in the vertical soft iron, we will use the soft iron for correction of IP. So vertical soft iron is used for correction and it is used in the form of Flinders bar. The value of induced magnetism depends upon the length of the soft iron. Hence, the length of the Flinders bar is varied as per the correction required. I'll explain this to you in detail now. Now, when we are doing a correction with permanent magnets, we can easily control the magnitude of correction by increasing or decreasing the number of magnets used. But what to do in case of a soft iron or in case of induced magnetism? The magnetism which will be induced is not in our control. It is dependent upon the magnetic field of the earth. So how can it be controlled or magnitude changed? Now that can be done by changing the length of the soft iron which is used as a corrector. The longer the soft iron, the more induced magnetism it is going to attain or have. So if we require a greater correction, then we use a longer Flinders bar, and in case the correction required is minute, then we can shorten the length of the Flinders bar as per our requirement. Now going more into analyzing the Flinders bar. The Flinders bar is placed inside a brass case. It could be a brass case, or it could be a plastic, or it could be any material which is non-magnetic. Now all the items which are used close to the magnetic compass in the binnacle, even the nails and screws which are used, they are made up of non-magnetic material. Only the correctors which we are using, they are either the permanent magnets or they are the soft iron rods or soft iron structures. Other than that, all the other parts of the binnacle are made up of non-magnetic material. So Flinders bar is placed inside a brass case or a non-magnetic case, and its length is 610 millimeters. And this casing is attached to the binnacle. The soft iron bars which are put into this casing are provided in pieces. It is not that they provide us with a single length Flinders bar which is 610 millimeters long. What is provided is they break up the 610 millimeters into small portions or small parts, so that the compass adjuster can use the required parts or the required length of the Flinders bar. So I'll explain to you how this is used. Now the Flinders bar which is provided is in pieces. The first piece is 305 millimeters. Then the next piece is 152 millimeters. Then we have a piece of 76 millimeters, 38 millimeters, and then there are two pieces of 19 millimeters, making a total of 610 millimeters. Now, why are these provided in small pieces? Because as we just now saw, to vary the magnitude of correction, we can change the length of the Flinders bar. So once these pieces are provided to us, we can use whatever pieces we require, and the other pieces can be kept as spare. So this is the approach behind providing the pieces. Now, how are these pieces utilized? When a Flinders bar is supplied on the ship, along with these soft iron bars of these dimensions, a complete set of wooden pieces of the same dimensions are also provided. So you will have wooden pieces of all these dimensions along with the soft iron bars also provided. Now this is given to help us vary the length of the soft iron as per our requirement. Now on a ship which has a very big funnel, huge funnel, let us say we have a VLCC and it has got a huge funnel. Now if the funnel is quite big, that tells us that the induced P on that particular ship is going to be substantial. So we may require a Flinders bar close to maybe 500 or 600 mm. Now on another vessel which has a very small engine and has a very small funnel, the correction required may not be very much. So we may require just about, let us say, 100 or 200 millimeters of the Flinders bar. So these wooden pieces help us to vary the dimension or length of the Flinders bar.
Sir, one doubt, sir.
Go ahead, beta.
Sir, these wooden pieces are normally for the length of to provide for the length of soft iron, not for regarding any the distance from like for correction purpose, right?
अभी बताता हूँ बेटा. I'll show you with the diagram. I'll show you how they are placed.
सर जो बस ये SI बार्स लिखा है इसका क्या मतलब?
Soft iron bars बेटा.
Copied soft iron.
Okay. Let me explain the use of the soft iron bar and the wooden bar for filling up the Flinders bar. So you see this is the Flinders bar present on a ship, and this is basically the casing in which the bar would be placed. The maker supplies us a soft iron bar in these dimensions. You see, one piece is for 305 mm, the next one is 152 mm, 76, 38, then two pieces for 19 mm. And along with the soft iron bar, he also provides a wooden bar of same dimensions. You see, we have the pieces with exactly same dimensions. So first of all, compass adjuster evaluates what length of the flinder bar he requires. Let us assume that on a particular shape, the compass adjuster has ascertained that he needs to use these two pieces, 305 mm and 152 mm. What he does now is, leaving these two pieces, 305 and 152, 305 and 152, he will pick up all the other pieces of the wooden bar. So you see all these pieces with a green tick mark, other than the ones which are required, other than 305 and 152, he will pick up all the wooden pieces, 76, 38, 19 and 19, and he will pick and drop these pieces in the flinder bar casing. So let us put these pieces here. You see all these four pieces coming here, 19 mm, 19 mm, 38 mm and 76 mm. All these four pieces coming here, these are the wooden bar pieces. Now once these wooden pieces are placed at the bottom of the flinder bar casing, he now picks up the required soft iron pieces, 152 mm and 305 mm, and he drops these pieces into the flinder bar. So you can see this 152 mm piece and the 305 mm piece dropped in the flinder bar, and now you can see the top end of the soft iron bar will be in level with the compass card or as required. So the bottom portion is filled using the wooden pieces, thus making the flinder bar correction. Is it clear now, beta?
Yes, sir. Clear, sir. Thank you.
Go ahead, Vaibhav.
Sir, do we have a diagram showing this in the actual binnacle? Where is it situated? Can we show it?
Okay, I'll show you, beta. I'll show you.
Sir, these wooden pieces, how many wooden pieces to be put is decided by the adjuster?
That's correct, beta. He will estimate the amount of induced B, and basis that he will decide how much length of soft iron and how much length of wooden bars he will be using.
Okay, sir.
Now when we are putting the flinder bar, the bar is so adjusted as to keep the top pole in level with the compass card. It should be so placed that the top pole of the flinder bar should be in level in the same horizontal plane as the compass card. So as IB is caused by the funnel which is aft of the compass, the flinder bar is placed forward of the compass to compensate its effect. The basic concept is, as you can see in this particular diagram, we have the binnacle here. The compass is located at this location. We have the funnel abaft of the compass, and it is getting induced by the Earth's magnetic field. Right now, the ship is in the northern hemisphere. In the northern hemisphere, the magnetic field lines, they go down into the surface of Earth. So that's why you see the top pole of the funnel is blue. This blue pole affects our compass and generates IB, induced B. Now what have we done here is we have placed a flinder bar forward of the compass. The flinder bar is also made of soft iron. So when you place this flinder bar, this also gets induced by the Earth's magnetic field and generates a blue pole on the top end. Now this blue pole forward of the compass cancels out the effect of the flinder bar which is abaft of the compass. Go ahead with your doubts, beta.
सर जो हम लोग लास्ट वाला जो कर रहे थे उसमें जब भी हम लोग फिल्टर्स बार्स के लिए एडजस्ट कर रहे थे देन वी वी आर यूजिंग द अपोजिट वन लाइक जिसका ब्लू पोल था उसका रेड के साथ कर रहे थे और
Right.
रेड वाली पोलैरिटी का ब्लू के साथ। यहाँ पे सर सेम ही डायरेक्शन रहेगा करेंगे इसमें?
ओके अब देखो बेटा जो पुरानी करेक्शन हम कर रहे थे दैट वाज विद परमानेंट मैग्नेट्स। परमानेंट मैग्नेट के पोल्स हमारे हाथ में हैं वेदर वी वांट टू यूज रेड और ब्लू। बट ये जो करेक्शन हम कर रहे हैं वी आर डूइंग इट विद ए सॉफ्ट आयरन करेक्टर और इसमें तो इंडक्शन अर्थ के मैग्नेटिज्म से होगी। तो यहाँ हमें करेक्शन के लिए टॉप पे ब्लू पोल ही मिलने वाला है, इसीलिए हमने करेक्टर को फनल के ऑपोजिट लगा दिया है। If you have same poles in the opposite direction, they will cancel out each other. Getting clear, beta?
यस सर जस्ट अगर हमारा फनल जो होता है अगर इन केस जस्ट फॉर अंडरस्टैंडिंग अगर ये हम लोग इसको फॉरवर्ड में कर देते तो जो हमारा
Right.
फिल्टर बार है हम उसको ऑफ में लगा देते कंपास बार
बिल्कुल
के।
बेटा, that's correct. Flender bar will be in opposite direction to the soft iron.
ओके सर थैंक यू सर।
Let me show you a actual Flender bar also, the diagram.
Sir, one quick recap. Sir,
go ahead.
The PB is corrected by placing permanent magnets, pair of permanent magnets, and IB is corrected by the Flinders bar. That's it, right?
Right. That's correct, beta.
Nothing else.
Nothing else. Nothing else.
Okay.
बाकी और करेक्टर भी आएंगे but they will come under C, D and E, Charlie, Delta, Echo.
Yeah, for now only this one.
Yeah, that's correct. Let me show you the actual diagram. Any more doubts I'll take later. Let me now show you the location of the Flender bar. Now you see we have the binnacle here. This is the compass bowl. And then we saw in permanent B that we use 4.5 magnet placed in these trays. Now the Flender bar is placed in this housing, you see. This cylindrical housing which is there, it is fitted forward of the compass. So why it is fitted forward of the compass? Because it is compensating or correcting the magnetism of the funnel. The funnel is fitted aft of the compass. On a normal merchant vessel, you will have the funnel aft of the compass. So to counteract it, the Flender bar is placed forward of the compass. Any doubts now, beta, in IB?
No.
सर
Go ahead, beta.
सर ये इस तरीके से क्यों डिवाइड किया गया है? 305, 152, 76, 38 हम इसे 50-50 भी तो डिवाइड कर सकते थे, कोई स्पेसिफिक रीजन है सर?
ओके बेटा, ये एक्चुअली ना पुराने टाइम से ही ये चला आ रहा है एंड इन द ओल्डन टाइम्स people used to have that FPS system, foot pound and second system. तो इंचेस और फीट में ये होता था. सो बेसिकली ये इंचेस की जो डायमेंशंस हैं वो अब मिलीमीटर्स में कन्वर्ट कर दी गई हैं. सो दिस वाज जस्ट टू कीप इट इन ए सिंपल इंचेस फॉर्मेट. और ये ऐसे ही स्पेसिफिक फॉर्मेट में क्यों है, आप देखोगे सबसे बड़ा पीस जो है, नेक्स्ट पीस उसका हाफ है, नेक्स्ट पीस उसका हाफ है और नेक्स्ट दोनों उसके हाफ हैं. सो इट इज समथिंग सिमिलर टू जैसे ये कंप्यूटर की पेन ड्राइव्स आती है ना बेटा, मेमोरी पेन ड्राइव्स, 1 GB then 2 GB then 4 GB. You won't have something for 3 GB. 4 के बाद 8 आएगा, 6 GB नहीं होगा. So that is how it has developed over the years.
हमें लग रहा था कुछ उसका भी रीजन है. ठीक है सर.
No. It is because of the tradition which is going on. So they have kept it same.
Okay.
Okay, great. So this was induced B beta. इसके साथ हमारा coefficient B complete हो गया है. So Charlie is now very similar to B.
Sir,
B जो है ये, हाँ, go ahead.
Sir, in previous year question papers, there was a question in which they have slewed the Flinders bar to 15 degrees on one side.
करेंगे बेटा, let's do Charlie, उसके बाद slew कर देंगे.
Okay, sir. But sir, how to ascertain that if like suppose it says that constant deviation is there or some of this, so how to ascertain that what type of coefficient will be causing that? Because we have already covered two coefficients.
I'll tell you बेटा, don't worry. पहले सारे coefficient cover करेंगे, फिर ये सारे question cover up कर लेंगे.
Okay sir.
Okay?
Okay, thank you sir.
Because इसमें important है कि आपको ये basics एक बार mind में clear हो जाए, फिर कोई भी question आ जाए, सबको tackle कर सकते हैं.
Okay sir, thank you sir.
Okay.
And
So
sorry,
let's.
sir.
बोलो बेटा.
Particular reason for the 610 mm, the length being the maximum.
Okay. This is also because of experience. हमने ये देखा है कि नॉर्मल मर्चेंट वेसल्स में, रूटीन साइज मर्चेंट वेसल्स में, ये 610 mm की जो साइज है, दिस हैज बीन sufficient to counter the funnels effect. But it is also possible बेटा कि अगर कोई बहुत हैवी इंजन वाला शिप हो, you have a very powerful engine ship whose funnel is very very big, ऐसे केस में हो सकता है कि 610 से बड़ी सिलेंडर बार भी लगानी पड़े. So ऐसे केस में then the compass maker gives you a customized cylinder bar, a customized binnacle. That's also possible.
अरे भी एक कंटेनर शिप तो दो फनल वाले भी आ रहे हैं.
Yes, sir. This customized cylinder bar we have installed, sir, because of this scrubber unit which came, no? Because of that we have installed it, yes.
Right. So any new structure which comes up later on, or if the funnel is of a very big size, you can have a customized bar also which will exceed 610.
Yes.
Okay.
सर ये प्लस एंड माइनस का फंडा बताया नहीं सर.
हाँ, वो तो सारे कोफिशिएंट्स के बाद बताऊंगा बेटा. अगर इंटरेस्टेड हो तो अभी भी बता देता हूँ शॉर्ट में. कोई भी कोफिशिएंट की जो डेविएशन जनरेट हो रही है, लुक फॉर दैट डेविएशन बिटवीन नॉर्थ एंड नॉर्थ ईस्ट. नॉर्थ एंड नॉर्थ ईस्ट ये जो दो हेडिंग्स हैं, इनके बीच में क्या डेविएशन प्रोड्यूस हो रही है, वेदर इट इज ईस्टर्ली और वेस्टर्ली, दैट डिसाइड्स वेदर ए कोफिशिएंट विल बी कॉल्ड प्लस और माइनस. अगर ईस्टर्ली डेविएशन जनरेट हो रही है, द कोफिशिएंट इज कॉल्ड पॉजिटिव. अगर वेस्टर्ली डेविएशन जनरेट हो रही है, द कोफिशिएंट इज कॉल्ड नेगेटिव. ये मैं बाद में डिटेल में भी एक्सप्लेन कर दूंगा.
ओके सर.
ओके. अब बेटा लेट्स टेक ए क्विक 5 मिनट्स ब्रेक और फिर कोफिशिएंट सी पे चलते हैं, राइट?
Yes.
Okay, sir. Thank you.
Great. Let's see you. ये बेटा आ गए वापस बैक?
Sir.
Okay, great. So shall we move on to Charlie C?
Yes, sir.
Okay, let's go beta. Now let's move on to our next coefficient, which is coefficient C. Coefficient C is the maximum value of the semicircular deviation, which varies as the cosine of the compass course. It is caused by the horizontal authorship component of the ship's magnetic field. Now, if you look at the definition carefully, you will understand and realize that this definition is very much similar to coefficient B. In fact, coefficient C is almost having the same properties as we discussed in coefficient B, with only one difference. Bravo and Charlie, both these coefficients are exactly similar with only one difference. Coefficient C is dependent upon or is related to the authorship component of the ship's magnetic field. The last coefficient which we discussed, that is coefficient B, it was dependent upon the fore and aft component of the ship's magnetic field. And coefficient C is dependent upon the authorship component of the ship's magnetic field. Exactly like coefficient B, which had two components, the coefficient C also has two components. Coefficient C comprises of permanent C as well as induced C. Moving ahead now, beta. So moving on to permanent C. Permanent C is caused by the Q component of the ship's permanent magnetism. We have three components of the ship's permanent magnetism, that is P, Q and R. P component lies in the fore and aft direction, Q component lies in the authorship direction, and R component lies in the vertical direction or orientation. So this is caused by the Q component, that is the authorship component of the ship's permanent magnetism. Now, to understand it more clearly, let's assume that we have a ship which is built in a yard on a easterly heading. Now, if the ship is built on a easterly heading, the magnetic lines of force will be entering into the ship's hull from the starboard side. So because of that, the starboard side will acquire blue polarity and the magnetic lines of force will be leaving out or coming out of the port side of the ship. So it will acquire a permanent red pole on the port side and a permanent blue pole on the starboard side. If a ship is built on a westerly heading, for a vessel built on a westerly heading, it will have the poles in the opposite direction. That means you will have a blue pole on the port side of the ship where the lines of force will be entering, and you will have a red pole on the starboard side of the ship where the magnetic lines of force will be coming out. Moving ahead now, beta. Let's now try to understand the deviation caused by coefficient C, that is permanent C. Now we are considering a ship which is built on a easterly heading. Just now we saw that a ship which is built on a easterly heading will have a blue pole on the starboard side and it will have a red pole on the port side. So you can see this ship in the diagram on different headings cardinal and intercardinal headings, and the starboard side of the ship has a blue polarity and the port side of the ship has a red polarity. You see the compass needle fitted on the ship. The north end of the compass needle, which points towards the north, is of red polarity. So you can see the red end pointing towards north. And the end of the compass needle towards the south direction has a blue polarity. So you can see the blue polarity end pointing towards south. So let's try to analyze the deviation caused by this outward ship magnetism, that is permanent C, on different headings. Let us first consider the deviation caused on the northerly heading. So ship is heading north. You can see this topmost diagram shows the vessel heading in the northerly direction. Now when the ship is heading in the northerly direction, you can see that the blue pole of the ship, which is on the starboard side of the ship, is east of the compass needle. Now this blue pole of the ship is going to attract the red end of the compass needle, and the compass needle is going to swing clockwise. Looking from top, the compass needle is going to swing clockwise, which is easterly deviation. Likewise, on the port side, you see, on the port side, we have the blue polarity of the ship's magnetism. Sorry, the red polarity of the ship's magnetism. We have the red end. And this red pole of the ship's permanent magnetism is going to repel the red end of the magnetic needle, and again it adds on to, or it complements, the clockwise swinging of the compass needle looking from top. So we have a easterly deviation here. The red end on the port side repels the red end or the north end of the magnetic needle, and at the same time it attracts the south end or the blue end of the magnetic needle, resulting in the compass needle swinging clockwise looking from top, generating easterly deviation. And another important thing to note here is that these red and blue pole of the ship on the sides of the ship are at right angles to the compass needle, or you can say they are at right angles to the direction of the Earth's magnetic field. And when these poles, the ship's poles, are at right angles to the magnetic field of the Earth, they generate maximum deviation. So maximum easterly deviation is generated when the ship is on a northerly heading, 0, 0, 0 heading. Now let's take the ship on the easterly heading. Let us assume that the vessel is now heading 090. So on the easterly heading, you see in this part of the diagram, the blue and red poles which were present on the sides of the ship. The blue pole is on the starboard side and the red pole is on the port side of the ship. These poles are now exactly in line with the magnetic compass needle. The red pole is north of the compass needle and the blue pole is exactly south of the compass needle. Now, since these poles are exactly in line with the magnetic field of the Earth, they will not be able to generate any deviation at all. Deviation can only be generated when the poles are at some angle to the Earth's magnetic field or at some angle to the compass needle. So in this case, no deviation is generated. So that's why you see it is mentioned here, no deviation. Now you can see there is a red pole on the ship's port side, which is exactly north of the compass needle. The north end of the compass needle is also red. So if this was the only thing affecting the magnetic needle, that is these red and blue pole of the ship, this red pole will try to repel the compass needle, and it will try that the compass needle should point exactly southwards, because the red will be repelling the red end of the compass needle and it will be attracting the blue end of the compass needle. Likewise, you see the starboard end of the ship, which has a blue polarity, will try to repel the blue end of the compass needle, and it will also try to make the compass needle swing by 180 degrees pointing due south. But that does not happen. That does not happen because the ship's poles are much weaker as compared to the poles of the Earth. The magnetic poles of the Earth are much stronger as compared to the ship's magnetic field. Thus, these ship's magnetic poles are not able to generate any deviation at all. Now, if you take your attention to the ship heading in the westerly direction. Now, in the westerly direction, you see the situation is more or less the same. The poles are exactly north or south of the compass needle. The only difference in this case is that the blue pole is north of the compass needle now, and the red pole is south of the compass needle now. In this condition also, with the ship heading in the westerly direction, no deviation is generated because the ship's poles are exactly in line with the magnetic field of the Earth, or they are exactly in line with the compass needle. When the poles are in line with the magnetic field of the Earth or the compass needle, they are not able to generate any deviation at all. So on the westerly heading, no deviation is generated. Now let's go to ship on the southerly heading. We have the ship on the southerly heading here in this part of the diagram. Now when the ship is heading south, you can see that these red and blue poles of the ship are now at right angles to the compass needle, or at right angles to the magnetic field of the Earth. So when these are at right angles, they will generate maximum deviation. So what type of deviation will be generated here? You see the starboard end of the ship, or the starboard side of the ship, has a blue polarity. This blue is going to attract the red end of the compass needle towards it. So the north end of the compass needle is attracted towards the port side of the ship, and the south end of the compass needle, which also has a blue polarity, is repelled away from this blue pole of the ship. Thus, the compass needle now swings anti-clockwise, generating a westerly deviation. Likewise, the red pole which is there on port side of the ship repels the red pole, or the north pointing pole of the compass needle, and attracts the blue pole of the compass needle. So thus adding on to this anti-clockwise swing of the compass needle, or adding on to the westerly deviation generated. So you can see when the ship is on southerly heading, westerly deviation is generated, and since the poles are at right angles to the compass needle, this deviation generated is the maximum deviation. Now let's take one intercardinal heading also. If you take the ship on a northeasterly heading, you can see on the northeasterly heading, the port side of the ship having a red polarity is now northwest of the compass needle, and it will repel the red end of the compass needle, generating a easterly deviation. Likewise, the blue end on the starboard side of the ship repels the blue end of the compass needle. This is southeast of the compass needle now, again generating a easterly deviation. So again a easterly deviation is generated, but this easterly deviation is lesser than what it was on the northerly heading, because on the northerly heading the ship's poles were at right angles to the compass needle, whereas on northeasterly heading the ship's poles are not at right angles, they are at a 45-degree angle now to the compass needle. So you can see this happening on the other intercardinal directions also. So what we observe here is that maximum easterly deviation is generated on the ship heading north. When the ship is heading northeast, this easterly deviation reduces. With the ship heading in the east direction, the deviation is zero, nil deviation. When the ship heads in the southeast direction, now a westerly deviation is generated. The deviation has changed its name now. When the ship is heading in the southerly direction, maximum westerly deviation is generated. With the ship heading in the southwest direction, again you have a westerly deviation. With the ship heading in the westerly direction 270, you have no deviation at all. And with the ship heading on the northwest heading, the needle or the compass has a easterly deviation. So you can see from 270 going up to 090 for this semicircle, the deviation is easterly, and from 090 onwards going up to 270 in this semicircle, the deviation is westerly. So this tells us this is a semicircular deviation, and it also tells us that the deviation is proportional to cos of the compass course. Cos of 0 and cos of 180 is of maximum magnitude, that's why you see maximum deviation here. Cos of 90 and cos of 270 has 0 magnitude, that's why you see 0 deviation on both these headings. Now we can also appreciate the result of these magnetic fields or the magnetism of the ship on the directive force. So any doubts up to here, beta, before we proceed ahead?
सर दिस इज जो लास्ट स्लाइड में मेंशन किया गया था कि शिप कंस्ट्रक्टेड फेसिंग ईस्टर्ली, राइट? तो
That's correct, beta.
वेस्टर्ली का अलग से अलग होगा कि वो भी सेम है?
आप चाहो तो वेस्टर्ली हेडिंग भी अपनी एग्जाम्पल में ले सकते हो। उसमें डिफरेंस ये आ जाएगा बेटा, पोल्स की डायरेक्शन चेंज हो जाएगी, स्टारबोर्ड साइड में रेड पोल आ जाएगा, पोर्ट में ब्लू आ जाएगा, और जैसे अभी ईस्टर्ली डेविएशन हो रही है ऑन नदरली कोर्सेज, तो वो चेंज होके वेस्टर्ली बन जाएगी बेटा. दैट विल बी द ओनली डिफरेंस विच विल कम. द डेविएशन इज गोइंग टू चेंज इट्स नेम.
And sir, what about hemisphere, sir? How will know which hemisphere it is constructed?
How will you know which heading the ship is constructed? This is your question, beta.
Hemisphere, south or north?
इसमें बेटा हेमिस्फीयर का तो कोई रोल ही नहीं है, क्योंकि ये तो हॉरिजॉन्टल मैग्नेटिज्म की वजह से जनरेट हो रहा है ना. तो हेमिस्फीयर चेंज होने से तो वर्टिकल पोजीशनिंग चेंज होती है पोल्स की. ओके, सो इस केस में आप चाहे नॉर्थ हेमिस्फीयर में शिप बिल्ट हुआ हो या साउथ हेमिस्फीयर में बिल्ट हुआ हो, it will not have any effect on permanency. What will have the effect is the heading of the ship, only the heading.
Only the heading, no sir worry about hemisphere.
Right. हेमिस्फीयर का जो इफेक्ट आएगा वो जैसे आई बी हमने किया था इंड्यूस्ड भी, उस पे आएगा. अभी इंड्यूस्ड सी करेंगे, उस पे भी हेमिस्फीयर का इफेक्ट आएगा.
Okay sir.
Sir,
go ahead, beta.
Considering the northern heading and the eastern heading of the vessel in this diagram, sir, for when the vessel is pointing towards east, we said that the effect of the poles created, the port and starboard poles created, will not be there. So the directive force will be maximum, and there will be no deviation, right? But when
there is a maximum reduction in the directive force, beta, so the directive force will be minimum on easterly heading.
Yes, sorry. Directive force will be minimum because the red is pointing towards blue of Earth, and the blue of ship is pointing towards red of Earth. But sir, in this case, the needle is not turning 180 degree because the Earth's magnetism is stronger than the magnetism acquired by the ship, the port and starboard magnetism.
That's
but
correct,
sir, because of this, the needle is not at all moving. Whereas when we consider the ship facing north, the needle is actually deviating because of the poles created on the ship rather than the Earth's magnetism.
Okay.
If the ship's poles are stronger, then only
मैं समझ गया बेटा. अभी बताता हूँ आपको, I'll show this in the whiteboard. Just give me a minute.
Okay, sir.
Sir?
Just a minute बेटा, let me explain this first, फिर मैं next out लेता हूँ. Okay. अब बेटा हम शिप को नॉर्थ ईस्टर्ली हेडिंग पे ले जाते हैं. ये मैंने शिप को नॉर्थ ईस्टर्ली हेडिंग पे बना दिया। अब हमारे शिप पे हमने 2 पोल कंसिडर किए हैं। We have a blue pole on the starboard side of the ship, so let's make a blue pole here. And we have a red pole on the port side of the ship, let's make a red pole here. Okay. अब ये जो बेटा शिप का मैग्नेटिज्म जनरेट हुआ है ना, कंसिडर दिस एज ए वेक्टर। कंसिडर दिस एज ए वेक्टर। ये कैसा वेक्टर है? इट इज ए वेक्टर विच इज गोइंग फ्रॉम रेड टू ब्लू। ऐसा वेक्टर है ये बेटा।
Yes, sir.
लाइक दिस। अगर हम शिप के मैग्नेटिज्म को एक वेक्टर में डिनोट करें, सो दिस वेक्टर वुड लुक समथिंग लाइक दिस। अब ये जो वेक्टर है इसको 2 कंपोनेंट में डिवाइड करना है आपने। कौन से 2 कंपोनेंट में? एक तो इसे डिवाइड करो इसके ईस्ट वेस्ट कंपोनेंट में, ये इसका ईस्ट वेस्ट कंपोनेंट हो गया। और एक इस वेक्टर को डिवाइड करो इसके नॉर्थ साउथ कंपोनेंट में, ये इसका नॉर्थ साउथ कंपोनेंट हो गया। वी कैन रिजॉल्व द वेक्टर्स ना, सो दैट इज हाउ वी हैव रिजॉल्व्ड दिस वेक्टर। अप टू हियर ओके बेटा?
Yes, sir.
ओके। अब बेटा जो इस वेक्टर का, शिप्स मैग्नेटिज्म वेक्टर का ईस्ट वेस्ट कंपोनेंट है, दिस ईस्ट वेस्ट कंपोनेंट डिसाइड्स द डेविएशन। ये ईस्ट वेस्ट कंपोनेंट ही डेविएशन को डिसाइड करेगा। जितना ये ईस्ट वेस्ट कंपोनेंट पावरफुल होगा, डेविएशन उतनी ज्यादा होगी, बिकॉज डेविएशन इज डिस्टर्बिंग द कंपास फ्रॉम नॉर्थ साउथ डायरेक्शन टूवर्ड्स ईस्ट और वेस्ट। अब अगर आपको ईस्ट और वेस्ट में उसे डिस्टर्ब करना है, द फोर्स हैज टू एक्ट इन द ईस्टर्ली और वेस्टर्ली डायरेक्शन। सो ये जो ईस्ट वेस्ट कंपोनेंट है, दिस डिसाइड्स द डेविएशन जनरेटेड। ओके। और ये जो नॉर्थ साउथ वाला कंपोनेंट है, दिस डिसाइड्स द इंक्रीज और डिक्रीज इन द डायरेक्टिव फोर्स। अर्थ का मैग्नेटिज्म नॉर्थ साउथ ओरिएंटेशन में है। मैग्नेटिक फील्ड लाइंस दे रन इन नॉर्थ साउथ ओरिएंटेशन। सो इस केस में, इस पर्टिकुलर केस में, विद द शिप हेडिंग ऑन ए नॉर्थ ईस्टर्ली हेडिंग, जो डेविएशन जनरेट होगी वो होगी ईस्टर्ली, एंड जो डायरेक्टिव फोर्स होगी उसमें आ जाएगी रिडक्शन, बिकॉज दिस एरो इज पॉइंटिंग डाउनवर्ड्स। ये एरो नॉर्थ की तरफ पॉइंट करता तो डायरेक्टिव फोर्स हमेशा बढ़ती। ये एरो साउथ की ओर पॉइंट कर रहा है, डायरेक्टिव फोर्स को ये रिड्यूस कर देगा। सो डायरेक्टिव फोर्स में आएगी रिडक्शन, देयर विल बी अ रिडक्शन इन द डीएफ। ओके। अब आप शिप को अगर ईस्टर्ली हेडिंग पे ले जाओगे बेटा, ईस्टर्ली हेडिंग पे, तो आप ध्यान से देखो जो शिप्स मैग्नेटिज्म है उसका ईस्ट या वेस्ट कंपोनेंट खत्म हो गया है। दैट इज व्हाई देयर इज नो डेविएशन। ओके। एंड जो पूरा का पूरा शिप्स मैग्नेटिज्म है वो अब नॉर्थ साउथ ओरिएंटेशन में लाई कर रहा है। दैट इज व्हाई इट हैज ए मैक्सिमम इफेक्ट ऑन द डायरेक्टिव फोर्स। नाउ यू कैन अप्लाई इट टू एनी ऑफ द हेडिंग्स एंड सी। देखो बेटा, आप डाउट सॉल्व हो रहा है?
Yes, sir. Solved, sir. Thank you, sir.
ओके, ग्रेट। हाँ, अब नेक्स्ट डाउट बताओ बेटा।
बस वही रिपीट कर रहे हैं सर। नॉर्थ साउथ फोर्स इज डायरेक्टिव फोर्स एंड ईस्ट वेस्ट फोर्स इज द डेविएशन।
या दैट्स करेक्ट बेटा, दैट इज करेक्ट। ग्रेट, चलें आगे बेटा।
सर ये बाजू में जो ग्राफ बना है वो क्या है सर?
जो ये कर्व बना हुआ है बेटा,
यस सर।
this basically gives us the direction of the deviation. नॉर्थ हेडिंग पे डेविएशन मैक्सिमम ईस्ट है, फिर वो रिड्यूस होती है, ईस्टर्ली हेडिंग पे डेविएशन 0 हो जाती है, देन as you go toward south the deviation is westerly, south heading पे maximum westerly deviation है, and so on. So this is basically the deviation direction. It is a cosine curve. If you see properly, it is a cosine curve.
Deviation
Okay
card
बेटा?
वाली ग्राफ आ गया ना, more equal value to the deviation card भी आ गया।
या डेविएशन कार्ड का जो कर्व है वो भी एक साइन या कॉस के कर्व के साथ मैच करता है, बट उसके जो मैक्सिमम और मिनिमम पॉइंट्स हैं दैट विल वेरी।
ओके सर।
ओके, ग्रेट। क्लियर है बेटा, चलें आगे। Okay, let's go. Let's go back to the presentation. Let's now see the correction of this particular coefficient. Now, some important points which we are aware of is the coefficients are always corrected on the heading on which they produce maximum deviation. For the coefficients to produce or generate maximum deviation, it should be acting perpendicular to the compass needle or to the magnetic field of the Earth. Now in our case, you can see the maximum deviation is being generated on northerly heading and on the southerly heading. It is on north and south heading that the poles of the ship are at right angles to the magnetic compass. So this coefficient would be corrected on a northerly heading or on a southerly heading. Basic principle which is followed in correcting a compass is to cure like with like. That is, a permanent deviation is cured with permanent magnetism and induced deviation is cured with induced magnets. So in our case, this is being generated because of permanent magnetism of the ship. So we will be using a permanent magnet to correct coefficient permanent C or PC. Moving ahead now. So as we just now saw, cure like with like principle is used in the correction. PC, which is caused by ship's outward ship horizontal. Okay, I'll show you better. Let us complete this. I'll show you the one.
Okay, sir, the last one.
Permanent magnetic field is therefore corrected using outward ship permanent magnets placed horizontally. They are so placed as to produce a permanent magnetic field at the compass location which is exactly equal and opposite to that of the ship. Now in the diagram you see this ship. We are looking at the ship from the stern. You see we have a blue pole on the starboard end of the ship and we have a red pole on the port end of the ship. This was generating coefficient permanent C. Now on top you see this represents the binnacle of the magnetic compass, and in the binnacle we keep the corrector magnet. This small magnet on top is the corrector magnet which is placed. The holes are made in the binnacle in the outward ship direction, and these magnets are placed in those holes, making sure that the ends of the corrector magnet are opposite to the ends of the ship's permanent magnetism in the outward ship direction. So this is the previous slide, beta.
Sir, please can you explain the last point which you said, last point on this one, that this permanent deviation is curved with the permanent magnets to induce deviation.
ओके बेटा, इसका मीनिंग ये है बेटा कि कोई भी डेविएशन अगर शिप के परमानेंट मैग्नेटिज्म से जनरेट हो रही है तो हम उसे एक परमानेंट मैग्नेट से ही करेक्ट करेंगे, और अगर कोई डेविएशन इंड्यूस्ड मैग्नेटिज्म से जनरेट हो रही है तो उसे सॉफ्ट आयरन से करेक्ट करेंगे.
ओके सर, तो ये कोएफिशिएंट से के लिए भी सेम ही रहेगा जैसे बी के लिए था.
Exactly, this will remain same for all the coefficient. सिर्फ एक जगह पे हम इसे फॉलो नहीं कर पाते, वो मैं आपको बताऊंगा when we go to the healing error.
ओके सर, थैंक यू सो मच.
Okay. Okay, great. So let's see the correction. The magnets which are used for correction are exactly similar to the ones which were used for correcting permanent B. So these outward-shaped magnets are bar magnets of circular cross-section, which are 8 inches long and having 3 by 8 inch or 3 by 16 inch diameters. Two thicknesses are usually provided by the compass makers. In case a powerful magnet is required, then we will be using the 3 by 8 inch configuration, and in case we need a not very powerful magnet, a 3 by 16 inch diameter magnet can be used. Slots are provided in the binnacle below the compass, and the magnets are placed two in a row side by side. This is exactly as we corrected the permanent B. Only difference was in permanent B, the magnets were placed in the fore and aft direction. In correcting permanent C, the magnets are placed in the outward-ship direction. Let me show you the diagram also where these outward-ship magnets are placed. So this is the same diagram which I showed you earlier, and you can see here that we have these outward-ship magnets also placed. These are also placed in pairs. One magnet is placed forward of the periscope pipe and another magnet is placed aft of the periscope pipe. So clear beta, permanent C placement?
जी सर सर पिछली स्लाइड एक बार और दिखा देंगे
Okay, अभी दिखा रहा हूँ बेटा. Yeah, here it is.
जी सर
Okay, all right. Okay, so बेटा अब IC कवर कर लें?
अपलोडेड होता है ये थ्योरी पार्ट सर बहुत हो गया आज के लिए
Okay, all right.
नहीं सर चलेगा सर सी कर लेते हैं ना एक सी छोटा सा ही तो पार्ट है इंड्यूस्ड है उस
It is similar to IB, very similar to IB, so ज़्यादा load नहीं आएगा बेटा. It is similar, only thing the direction will change. Okay, let's do it.
सर उसके पहले
Go ahead.
एक छोटा सा डाउट है सर सर
बोलो.
coefficient A is not applicable on board because of symmetry of the vessels. B and C will always be applicable, no? Or if the ship is exactly north or south, only will not be applicable, made on north or south.
Right.
Yes. So
if the ship is built on a perfect north or east or south or west heading, which is very rare, because yard की जो direction होगी that is going to be any oblique direction. But अगर
Yes.
cardinal heading पे कोई ship बना है तो उसमें हो सकता है कि एक इन दोनों में से एक coefficient missing हो.
Cardinal में, okay. Intercardinal में both of them would be there.
Both of them would be there.
Okay. Yeah.
Right. Okay. So let's see IC also. थोड़ा सा देख लेते हैं, फिर जहां तुम बोलोगे तो रुक जाएंगे. So let's go. Let's now move on to the second component of coefficient C, coefficient Charlie, which is induced C, in short known as IC. IC or induced C is caused by a horizontal outward-ship magnetic field due to the induced magnetism in the vertical soft iron to port or to starboard of the compass location. So you see in this case, very similar to coefficient IB. IB was caused because of a vertical structure which is forward or aft of the compass, and IC is caused because of a vertical structure which is port or starboard of the compass. Practically, IC does not exist on a merchant vessel, as the vertical soft iron to port and starboard of the ship's center line, if it is there, is symmetrically placed. So practically you see coefficient induced C or IC is not present on most of the merchant vessels because number one, there is hardly any prominent vertical soft iron structure to port or to the starboard of the compass location. Forward or aft of the compass, we have substantial VSI, big VSI structures. It could be the mast, it could be a crane or a derrick kind of structure. But port and starboard of the compass location, we usually do not have a prominent vertical soft iron structure. So if that structure is not there, coefficient IC or induced C will not be generated.
Sir, on tankers, we have a provision crane on both port and starboard side. What about them? They will have the effects of
बेटा अगर ये दोनों साइड है, पोर्ट और स्टारबोर्ड दोनों तरफ प्रेजेंट है, फिर तो वो जनरेट नहीं करेगा क्योंकि ऑपोजिट साइड में अगर स्ट्रक्चर आ जाते हैं दे विल कैंसल आउट ईच अदर. बट अगर आपकी क्रेन या कोई भी वर्टिकल स्ट्रक्चर सिर्फ एक ही साइड में है, जैसे somebody may have a crane only on the starboard quarter, one crane, then it will generate IC, induced C. But it also depends upon कि कितना steel use हुआ है, how much steel is used and how much is the distance between the compass and that structure. अगर वो बहुत छोटा structure है और compass से दूर है, even a structure on one side may not have a substantial IC.
Okay, sir. Thank you.
Now, what about some of the small ships where they have this rescue boat? I forgot the name.
Rescue boat David?
Yes, a rescue boat David or the lifeboat David. Will they affect them?
बेटा रेस्क्यू बोट डेविड तो बहुत हल्की कंस्ट्रक्शन का है. Hardly 1 or 2 tons of steel may be used, so that may not have a effect. But कई ships में आप देखोगे sometime what happens is the cranes may be off centered. हो सकता है कि क्रेन स्टारबोर्ड साइड में ही है या पोर्ट साइड में ही है. So अगर ऐसा केस है and the vertical a substantial amount of steel is used in making that VSI, then certainly yes, it will have a IC also.
Compressor room crane?
सी बेटा इट ऑल डिपेंड्स अपॉन के स्ट्रक्चर कितना बड़ा है और कंपास के कितनी पास है.
ओके. कंप्रेसर रूम क्रेन सर कंपास के एकदम एक्चुअली तो अकोमोडेशन से बड़ा नजदीक होता है और वो उसके ऊपर ही होता है और होता भी स्ट्रक्चर बड़ा ही है सर. मतलब एक प्रोविजन क्रेन जितना 5 टन से 3 टन के बीच में लोड लेना चाहिए उतना ही बड़ा होता है.
Okay, now the test whether it is affecting your compass or not is to look at the location of the flinder bar. अगर IC आपके शिप पे होगा तो फ्लिंडर बार बिनेकल में फॉरवर्ड नहीं लगी होगी, it will be at some angle.
ओके ओके सर.
ओके,
वहाँ कैंसिल हो जाएगा.
राइट. सो वो it will. Okay, so if it is fitted at an angle that tells you उस शिप में IB और IC दोनों प्रेजेंट है. जब हम IC की करेक्शन करेंगे ना, इसके बाद मैं आपको कंबाइंड करेक्शन कराऊंगा, दैट विल बी टुमारो. सो कंबाइंड करेक्शन में फ्लिंडर बार स्लू हो जाएगी, टर्न हो जाएगी, सो देन इट विल बी क्रिस्टल क्लियर. ओके, लेट्स सी इट.
सर एक डाउट था थोड़ा सा.
हाँ बोलो बेटा.
सर ये इंफॉर्मेशन हमें मतलब कहाँ से मिलेगा कि मतलब ये कोफिशिएंट एप्लीकेबल है या वेसल मतलब कौन से उस पे हेडिंग पे या यार्ड पे बना हुआ है, इसका कुछ इंफॉर्मेशन मतलब.
2 तरीके हैं बेटा ये पता करने के कि किसी शिप में कौन सा कोफिशिएंट होगा या नहीं होगा. 2 मेथड्स आर देयर. यू कैन म्यूट योर माइक नाउ. पहला तरीका तो ये है कि अगर आपको ये पता चल जाए कि आपका शिप कौन सी हेडिंग पे बना है और किस लोकेशन पे बना है, विच इज़ यूजुअली अवेलेबल. शिप पे हमारे पास ये इन्फॉर्मेशन होती है कि कौन सी यार्ड में शिप बना है, उसका लेट लॉन्ग क्या था, नॉर्थ हेमिस्फीयर या साउथ हेमिस्फीयर, and what was the heading of the ship when it was built. So the documents which are there with the master, they have all this information. If you get hold of that information, that immediately gives you an idea कि उस शिप पे कौन कौन से कोफिशिएंट प्रेजेंट है। इसीलिए हो सकता है कि कभी कंपास एडजस्टर आपके शिप पे आ रहा हो, ही में डिमांड दिस इंफॉर्मेशन फ्रॉम यू। दैट इज नंबर 1। अब नंबर 2, अगर ये आपको नहीं पता चला कि शिप कहाँ पे बना था, इट वॉज ए सेकेंड हैंड थर्ड हैंड शिप, नो इन्फॉर्मेशन इज देयर, कौन सी हेडिंग पे बना था वो भी नहीं पता है, देन द नेक्स्ट थिंग इज you can judge the coefficients from the deviations generated. आप शिप को अलग अलग हेडिंग पे ले जाओ, नॉर्थ पे, नॉर्थ ईस्ट पे, ईस्टर्ली पे, साउथ ईस्ट पे, कार्डिनल एंड इंटर कार्डिनल हेडिंग पे जाके आप उसकी डेविएशंस को नोट करो। जैसे ही आप उसकी डेविएशंस नोट करोगे, those deviation will give you the value of the coefficients. ये कैसे आती हैं, ये मैं आपको कंपास करेक्शन में बताऊंगा। ओके
यस सर, आप बी के लिए बस
ओके
करें सर।
ओके, 1 मिनट दे दो बस मुझे, 1 मिनट दे दो बेटा। ये देखो, मैं तुम्हें एक चीज दिखा देता हूँ। सो ये मैंने आपको इंड्यूस्ड सी के बारे में बताया। अब ये इंड्यूस्ड सी कैसे प्रेजेंट हो सकता है, एक तो शिप के
नहीं आ
पोर्ट
रहा है
और
सर स्क्रीन पे कुछ नहीं आ
सॉरी
रहा है,
सॉरी, ओके
स्क्रीन
ओके,
में
आई
नहीं आ
फॉरगॉट
रहा
टू
है कुछ।
शेयर। हाँ अभी शो कर रहा हूँ बेटा। ओके, सो आईसी बेटा प्रेजेंट हो सकता है अगर कंपास के पोर्ट या स्टारबोर्ड में कोई स्ट्रक्चर हो, और इफ द कंपास इज ऑफ द सेंटर लाइन। जैसे एयरक्राफ्ट कैरियर्स में आप देखते हो कि कंपास जो है वो एक साइड में हो जाती है, बिकॉज द ब्रिज इज पुट ऑन ए साइड टू मेक प्लेस फॉर द रनवे। तो ऐसे केसेस में आईसी प्रेजेंट हो सकता है, एंड दिस इज द आईसी डेविएशन। एग्जैक्टली जैसे आईबी में हमने एक ब्लू पोल कंपास के आफ्ट में बनाया था, यहाँ पे हमने एक ब्लू पोल कंपास के स्टारबोर्ड में बना दिया है। एंड यू विल सी द डेविएशन विच इज जनरेटेड is proportional to cos of the compass course. It is maximum on north and south and 0 on east and west. So this is the IC deviation. ये जो मैंने notes आपको भेजे हैं उसमें this diagram is there. So just have a look at this diagram. You should be able to understand. And quickly मैं आपको इसकी correction भी बता देता हूँ। Exactly जैसे हमने IB की correction की थी, we applied a flinder bar opposite to the funnel. इसमें भी हम एक फ्लिंडर बार लगाते हैं ऑपोजिट टू द वर्टिकल स्ट्रक्चर। जैसे यहाँ पे आप देख रहे हो वर्टिकल स्ट्रक्चर कंपास के स्टारबोर्ड साइड में है, तो हम कंपास के पोर्ट साइड में एक फ्लिंडर बार लगाएंगे और बिल्कुल उसे आईबी के जैसे ही करेक्ट करेंगे। सो दिस इज इंड्यूस्ड सी करेक्शन। क्लियर अप
सर
टू
इसका
हियर
मतलब
बेटा?
दो फ्लिंडर्स बार होंगे क्या?
राइट, सो दो फ्लिंडर बार होंगे। अगर किसी शिप में आईसी है, दो फ्लिंडर बार लगेंगे, एक फनल के ऑपोजिट लगेगा, एक वर्टिकल स्ट्रक्चर के ऑपोजिट लगेगा। अब आपके पास एक तरीका है कि आप उन दो को एक में कन्वर्ट कर सकते हो। कैसे? ये देखो,
एंगल
ये
पे।
हमारे पास एक शिप था, इस शिप में आईबी भी था और आईसी भी था। हमने दो फ्लिंडर बार लगाने थे। हमने क्या किया, इन दोनों का रिजल्टेंट निकाला और रिजल्टेंट के ऑपोजिट एक सिंगल फ्लिंडर बार के साथ इन दोनों को करेक्ट कर दिया। सो ये मैं आपको कल डिटेल में कराऊंगा, आईबी और आईसी को हम लोग एक साथ कैसे करेक्ट करते हैं।
ओके सर, क्लियर।
क्लियर सर।
ओके, इस
Sir,
पे एक
in
छोटा
this,
सा
we
न्यूमेरिकल
are
भी
just
आता है पेपर में, सो वी विल सी दैट न्यूमेरिकल आल्सो बट लिटिल लेटर। हाँ,
ओके
गो
सर।
अहेड बेटा।
sir, in this, we are just assuming that vertical structure will be on the starboard.
यस बेटा, वी आर अज्यूमिंग दैट देयर इज ए वर्टिकल स्ट्रक्चर ऑन द स्टारबोर्ड साइड। अगर ये पोर्ट साइड में आ जाए तो फिर फ्लिंडर बार क्लॉकवाइज स्लू हो जाएगी।
Okay.
Sir, IB and IC both are dependent on the VSI, correct?
Yes, both are dependent on
One
VSI.
is in the forward and aft direction, one is in the port and starboard direction.
Yes बेटा, that's correct.
Okay.
और अब इसे थोड़ा और इंटरेस्टिंग बना दें। अब
Yes,
देखो,
sir.
अगर कोई स्ट्रक्चर है, वर्टिकल स्ट्रक्चर, वो ना forward and aft है, ना port and starboard है. It is at a oblique direction. Let us say you have a big cargo crane which is on the starboard bow. Usually ऐसा होता नहीं है. Usually all the cranes are fitted on the center line, but let's assume कि कोई vertical structure है, वो कंपस के starboard bow की तरफ है, in the direction of the starboard bow. अब ना तो वो forward and aft exactly है, ना port and starboard exactly है, तो ऐसा structure IB और IC दोनों को generate करेगा.
ओके ओके
Okay, great.
जी सर, अभी शिप्स में सेल लगे हैं, शिप्स में सेल वापस लग रहे हैं, तो उसमें यही है सर, मतलब starboard साइड में the sales are coming up for that same reason. Corrections वो चेंज करते हैं, अभी वो changing the correction.
राइट बेटा. तो वो वर्टिकल स्ट्रक्चर लगेंगे तो आपकी कंपास करेक्शन और थोड़ी कॉम्प्लिकेट हो जाएगी. सो यू विल हैव टू लुक फॉर फिटमेंट ऑफ द फ्लिंडर्स बार. ओके ग्रेट. तो मैंने अब तुम लोगों को थोड़ा बहुत कंपास एडजस्टर बना ही दिया है. बाकी का अगले 2 सेशन में मैं बनाने वाला हूँ.
थैंक यू सर.
बोलो बेटा.
आपने जो अभी 2 सेंटेंस बोले थे ना, वो एक बार रिपीट करेंगे सर, रिगार्डिंग द पोर्ट एंड साबित करने के कंपास.
बेटा कहाँ पे डाउट आया है, कैन यू स्पेसिफाई? मैं ये बोल रहा था बेटा, अगर कोई स्ट्रक्चर हो विच इज नीदर फॉरवर्ड एंड आफ्ट नॉर एग्जैक्टली पोर्ट एंड स्टारबोर्ड, ये बीच में कहीं पर भी आ जाए.
2 sentences couple of minutes ago regarding the port side of the compass and starboard.
I said if there is a structure which is neither forward and aft nor port and starboard, somewhere in between it is there, it will generate both IB and IC.
Okay sir, copy.
Okay. Great beta. So that's all from my side. Anything you wish to ask or share? Okay, great. So let's break off for today beta. आपका एक डाउट था रडार प्लॉटिंग का, so let me have a look at that. If I could answer over the group, I'll share the answer. Otherwise, we'll discuss. Okay, all right. So see you in tomorrow's class, beta. Bye bye. All the best till
Thank you, sir.
tomorrow.
Thank you, sir.
Bye bye.
Good night.
Thank you, sir.
Good night. Thanks.